Okay, guys, welcome. Today we're going to talk about evaluating and simplifying radical expressions. Okay, so I first want to call your attention to some basic properties of radicals here. Okay, now the first one we've already sort of talked about, and that's if you have the nth root of something to a power, we could just as easily say that that's the nth root of b raised to that m power. And then, of course, in fractional forms, these look like b to the m to the 1 over n, or we could say it this is b to the 1 over n on the inside first to the n. Okay. Now, this next one here is going to be very important for simplifying radicals. And this says that if we have the product of two numbers, each in their own square root, we can say that this is equal to the nth root of their product, right? And this is going to be key, excuse me, for simplifying radicals. Okay, now this one says that if you have the quotient of two numbers with the same type of root, we can say that that's just the nth root of their quotient. All right, so that's sort of similar to the product one. Right, now if you have a to the n and then take its nth root, most of the time we just say that this cancels, the nth root and the n cancel and you just get a, but that's not necessarily true, right? You're going to get whatever a is if n is odd, and then you need the positive version if n is even. All right, so we need to be a little bit careful there. So we'll see some examples of that. Now, I want to give myself a little bit more room here, and I want to talk about how you can simplify simplifying numbers under radicals. Right, and we'll sort of do an example as we go. So let's say if we have something like the square root of 50. All right, now the goal is to write 50 as the product of two numbers where one is a perfect square. Right, or if you had a cube root, a perfect cube, or a perfect fifth root, you want a perfect fifth power, right? So here we can write 50 as the square root of 25 times 2, right? If we take 50 and we write 25 times 2, that's the same thing. And the advantage of that is that 25 is a perfect square, right? So now once you write the number that you're given as the product of two numbers where one is a perfect square, perfect whatever power that you're looking at, now you're going to use the multiplication property. Right? So now we can say this is equal to, well, it's the square root of 25 times the square root of 2. And now what's the square root of 25? It's just 5. So you get 5 square root of 2. Right? And that's the furthest that we can take it. All right. So that's how we're going to simplify numbers underneath radicals. So in part A, we have another example of that. We have the square root of 72. Right? Now, if you're not sure, list some perfect squares. So you have 1, 4, 9, 16, 25, 36, 49, 64, so on and so forth, right? Now, what you're doing is you're looking for one of these numbers to hopefully divide the thing under your square root. And of course, in this case, 36 will do the trick, right? So I can write 72 as 36 times 2. So this is square root of 36 times square root of 2. So I get a 6 times square root of 2. Okay. For part B, I have the cube root of negative 54. All right. So now I need to do something similar. I need to look at perfect cubes. So those are like 1, 8, 27, 64, and so on. Now, in this case, the number that will get this done is 27. So now, since I'm taking a cube root of a negative, this is going to definitely be negative. And I'm going to have cube root of 27 times 2. So this is negative cube root of 27 times cube root of 2. So I'm going to get a negative 3 cube root of 2. Okay, in part C, we have a 2 times cube root of 8x to the third y. So now here we have multiple things inside of our cube root, right? So now here, we're going to have 2. And what I first want to do is separate each of these. We're going to say this is cube root of 8. So using the multiplication rule times cube root of x to the third times cube root of y. Right? Now we know that the cube root of 8 is 2. Now for my variable terms, we're going to write this in fractional form. Right? And the last one I'm actually not going to do anything with because this is just going to remain cube root of y. There's nothing I can do with that. All right, but if you look at your x to the 3 over 3, we can simplify that because 3 over 3 is just 1. So we're going to get x. And this 2 times 2 is going to give me a 4. And I can't do anything else with the y, so this is 4x times cube root of y. Okay, and last but not least, in part D, we have a square root of 16x over 9y squared. Right, so we're going to say this is the square root of the top over the square root of the bottom. Now, I can say this is square root of 16 times square root of x over square root of 9 times square root of y squared. Right, I forgot this squared here. Well, square root of 16 is 4, square root of 9 is 3, and the square root of y squared is just y. So that's my answer for part D. Okay. Now, in general, when we simplify our radical forms, we can always simplify so that the exponent that's inside the radical is less than the type of root that you're taking, right? And of course, your number on the inside is prime. We can always do that. Now, in order to do this, and of course, you can always simplify so that there's no common factors as well. So in order to do this, you're going to convert to fractional exponent form. I could just say even exponent form. And you're going to write the exponent as a mixed number. Right? So when I say mixed number, I mean something like 3.5, right? Where you have a whole number plus a fraction. Now the whole number is the perfect power part, so that's just going to appear outside of a radical. Where the fractional, you'll convert back to radical form. All right, so let's take a look at an example of that. So in part A, we have square root of x to the third, y to the third. Right, so first of all, let's let's separate these. So we get x to the third, y to the third. Now, if we convert these to fractional form, we're going to get x to the 3 over 2 times y to the 3 over 2. Now, 3 over 2 as a mixed number is 1.5. Right? So now, if I separate this, sort of what I have in slow motion is I have an x to the first times a y to the first, and then I have an x to the 1/2 times a y to the 1/2, right? And again, you could always just multiply them back together and you get 1.5 for both, right? So I'm allowed to do that. But anything to the first power is just itself, and anything that's a 1/2 power is inside a square root. So we can simplify this one like this. Okay, let's look at part B. Part B, we have square root of 12 x to the 5th. Well, first things first is we'll separate. Now for 12, I want to write 12 as the product of two numbers where one is a perfect square. And of course, if you use 4, we can multiply it by 3 and get 12, so we'll do that. And x to the 5th, I'm going to write, or square root of x to the 5th, I'm going to write as 5/2. Right? So this is going to give me a square root of 4 times square root of 3. And then I'm going to get an x to the 2.5. So the square root of 4 is 2. So I get 2 square root of 3. And this is x squared times x to the 1/2. Well, this is 2x squared. I'm just going to bring that x squared out front. And then I'm going to get a square root of 3x because the x to the 1/2 is also in the square root. Okay. Part C, cube root of x to the 7th, y to the 6th. So first we'll separate. So now if I write this in fractional form, I'm going to get x to the 7/3, y to the 6/3. So now as a mixed number, this is x to the 2 1/3 times y squared. So we're just going to get x squared, y squared times the cube root of x. Okay, part D, we have a square root of 4xy to the 5th. So first things first, we'll separate each of this. Right, square root of 4 is 2, that's easy. The square root of x, the inside power is just 1, and that's already less than 2, so I don't need to do anything there. And the y to the 5th square root, we'll say, is 5/2. So this is 2 square root of x, y to the 2 1/2. So I'm going to get 2y squared, and then inside the square root, I'm going to get xy. Okay. Part E, we have the cube root of 16, x to the 4, y to the 6. So if we separate, we have 16, and then x to the 4th, and then a cube root of y to the 6. Now for the cube root of 16, I need a perfect cube and another number. So a perfect cube and another number that we could use would be 8 and 2, right? So this is a cube root of 8 times a cube root of 2. So that's going to give me a 2 cube root of 2. Okay, now if I do cube root of x to the 4th, that's going to be an x to the 4/3. And this cube root of y to the 6, that's y to the 6/3. Well, I'm going to get 2 cube root of 2. This will be an x to the 1 1/3. And this will just be y squared. So it looks like for whole numbers, I have a 2x and a y squared. And then inside my cube root, I'm going to get a 2x. Okay. Last but not least, we have part F, which is a 4th root of 16 and x to the 8th, y to the 5th. So if I separate, we have 4th root of 16, 4th root of x to the 8th, and a 4th root of y to the 5th. Right, so the 4th root of 16 is nice because that's just 2. And then we get x to the 8/4 once we convert y to the 5/4. Now the x is easy because that's just x squared. and the y will become a 1 1/4. So it looks like we get a 2x squared y and then a 4th root of y. Okay, so those are some examples of simplifying some radical terms. Okay, now the last thing that we need to discuss in this video is the idea of what's called rationalizing a denominator, right? So when you have radicals in the denominator, we want to get them out, right? So essentially what we need to do is to multiply by something that's going to result in a perfect power, right? So for example, we could say that this is 5 over 7 to the 1/2, right? How do I get this to be a full power? Well, I need another 7 to the 1/2, because if I add 1/2 and 1/2, I get 1. But I also need to do that to the top. So I'm going to get a 5 times 7 to the 1/2. And now on the bottom, I just have 7 to the 1, or just 7. And of course, this is 5 times the square root of 7 over 7. Now, most of the time we think of rationalizing denominator. We usually don't think of it as multiplying by 7 to the 1/2. We just multiply top and bottom by square root of 7, right? And of course, that's what would get you this, right? Now, the problem with doing that is if you have something like this next example, right? Because now if you multiply by the cube root of 2x squared, you're not going to get a perfect power, right? What we're going to have is this is 2x squared to the 1/3 now, right? So what do I need to multiply? Well, I actually need to multiply by this thing to the 2/3 now. I need to multiply by 2x squared to the 2/3 on the top and the bottom. That way, when I add those powers, I get 1. So now on the bottom, I get 2x squared. That's now perfect power, which is good. And then the top, I'm going to get a 2x squared all to the 2/3, which of course we can write as, if I square the inside first, I'll get a 4x to the 4th, take a cube root over 2x squared. Or we could just say that it's also the cube root of 2x squared all squared over 2x squared, right? Either one of these would be good. All right, but you have to be a little bit more careful on those. Okay, so let's do a couple of examples of rationalizing. So in part A, we have 1 over square root of 3. So in this case, we can get away with multiplying the top and the bottom by just the square root of 3, because then we'll get a square root of 3 over a square root of 9, which just is 3. So we get square root of 3 over 3. Okay, in part B, we have a 6xy squared over a 5 square root of 2x. Now, I only need to worry about making the square root part a whole power. So this is going to be a square root of 2x being multiplied on the top and the bottom. So now in the bottom, I'm going to get a 5 times 2x, right? Because that's now a perfect power. And I get a 6xy squared square root of 2x. So of course, the other thing I can do here is multiply 5 and 2, and this is now a 10x. And now we can cancel out these x's. And 6 over 10, we could think of as 3 over 5. So we get a 3y squared square root of 2x over 5. Okay. Part C, we have a negative 3x to the 5th, y to the 6th, over 4th root of x to the 3rd times y. Now, again, since this is this is like a x to the 3rd, y to the 1/4, I need to multiply the top and the bottom by an x to the 3rd, y to the 3/4 now. So now this is going to give me in the bottom, I'm going to get the x to the 3rd y, which is what we want. And then in the top, we're going to get a negative 3x to the 5th y to the 6. And if I write this in radical form, I get 4th root of x to the 3rd y all to the 3rd. So let's write it that way. And then, of course, we can cancel some stuff. We can cancel 3 of these x's. So we'll be left with 2. And I can cancel one of these y's with one of these, and I get 5th. So we'll get a negative 3x squared y to the 5th times the 4th root of x to the 3rd y all to the 3rd. Okay. And actually, if you really wanted to, you could continue this even further. You could say that this is negative 3x squared y to the 5th, and then a 4th root of x to the 9th y to the 3rd. And then what's going to happen is negative 3x squared y to the 5th. We'll get a 4th root, or sorry, I want to rewrite that. I want to rewrite this as x to the 9 over 4 y to the 3 over 4. So then I'm going to get negative 3x squared y to the 5th, x to the 2 1/4, y to the 3 over 4. So finally, we get negative 3x to the 4th from these two x's, y to the 5th, and then a 4th root finally of xy to the 3rd. All right, and of course, I would be happy with either one of these, but it just shows that you can have a couple different forms of the answer here. Okay, so what's the next one we got here? So the next one is part D, which is a square root of 3 over 7. Right, well, this is, of course, square root of 3 over square root of 7. So I need to get rid of that denominator being a square root, so we can multiply top and bottom by 7, and we're going to get a square root of 21 over 7. Okay, part E, we have a 2 over a square root of 6. So we need to multiply top and bottom by square root of 6. We get a 2 square root of 6 over 6. And we can reduce 2 over 6 to get 1 over 3. So this is square root of 6 over 3. Okay, part F, we have a negative 9xy to the 3rd over a square root of 3xy. Right, so again, when we have a square root, we can just multiply by the same thing. And if we do that in the bottom, we're going to get a 3xy, which is what we want. We have a negative 9xy to the 3rd, square root of 3xy up top. And then we can cancel the x's. We can cancel one of the y's from here. And then negative 9 over 3 is a negative 3 y squared, square root of 3xy. Okay, and then finally part G is a 5xy. Give myself a little more room. So a 5xy over the 4th root of 2x squared y. Right, so again, this is really like 2x squared y to the 1/4. And what we could even do is, let me show even another way that we could handle this, right? So we know that we could separate this into the 4th root of 2, 4th root of x squared, 4th root of y. All right, so now what does 2 need to be multiplied by in order to become a perfect power? Well, I need an 8, so that's a 16, which is a perfect 4th power. I would need 2 more x's to get a 4th power, so I need x squared. And I would need 3 more y's, to get a perfect fourth power, right? So this is an even more clever way to do it. And we can multiply, of course, we'd have to do the same thing up top. And now what happens? Well, on the bottom, the fourth root of 2 and the fourth root of 16 give me a fourth root of 16, which is just 2, right? X squared and x squared give me x to the fourth, and if I take the fourth root of that, I get x, right? And then y, fourth root of y times fourth root of y to the third, give me a fourth root of y to the fourth, which is just y. And then in the top, I'm left with 5xy times the fourth root of this mess all combined together now, right? And now we can just cancel the xy's and we're done. So we get 5 times a fourth root of 8x squared, y to the third over 2. Right? So that's another clever way that we can sort of approach this. Okay, so finally to finish up here, we can say that a radical expression is fully simplified when the inside power is less than the type of root that you're taking for all of your different variables. Of course, in your x is prime, your x and your m and n have no common factors. And of course, the last thing that we discussed is that your denominator is rationalized. All right, so let's simplify a couple of these, and I think that's the end, right? Yep, okay. So in part A, we have the fourth root of x squared y to the fifth. Well, for this one, of course, we'll separate first. And if we write these with fractional exponents, this is x to the 2 over 4, y to the 5 over 4. So I can simplify 2 over 4 as 1/2, and y to the 5 over 4 is 1 plus a fourth. So I'm going to get y times the square root of x times the fourth root of y. Okay. Part B, we have a square root of x to the third. I believe this is actually supposed to be the square root of the whole thing over y. Right, well, the first thing we'll do is we're going to separate everything. So this is square root of 8, square root of x to the third over square root of y. Now, the square root of 8, I can write as square root of 4 times square root of 2. The x to the third, we can write as x to the 3 over 2. And we're going to leave just square root of y just alone for a minute. Now, on the top, I'm going to get a 2 square root of 2 times x to the 1/2 over square root of y. So we're going to get a 2x square root of 2x over square root of y. So now, of course, we just need to rationalize. So we multiply top and bottom by square root of y. And we get a 2x square root of 2xy over now just a regular y. And there's our final answer. Okay, part C, we have a 6th root of x to the third over y squared. Right, so here we can think of this as the 6th root of x to the third over the 6th root of y squared. Well, if we write these in fractional form, you get x to the 3 over 6, y to the 2 over 6, and we can simplify each of those fractions. This will be 1/2, and this will be 1/3. Well, of course, this is square root of x over cube root of y, but now we need to rationalize cube root of y in the bottom. And to see what you need, just look over here. You need a y to the 2/3. So in the bottom, we know we're going to get y. And in the top, we get a square root of x and then a cube root of y squared. Okay. Part D, we have a square root of 18 x to the 6th over y. So we can simplify everything and we get a square root of 18 square root of x to the 6 over a square root of y. So 18 we're going to write as square root of 9 times square root of 2. Square root of x to the 6 we'll write as 6 over 3. And we're just going to leave square root of y alone for a second. So we're going to get 3 for square root of 9. X to the 6 over 3 will become x squared. And square root of 2 over square root of y. So now, of course, just multiply top and bottom by square root of y. And we get a 3x squared square root of 2y all over y. Okay. Part E, we have a cube root of ab to the 4th times a c to the 7th. Okay, so again, first things first is we'll separate. Did I miss something? Was that definitely it? Okay, yeah. So we'll write all these in fractional form. I don't really need to do a, but for completeness we will. If we write all these as mixed numbers, I'm going to get b to the 1 1/3. I'll get c to the 2 1/3. So it looks like my wholes are b to the 1st and c squared, and then I'm going to get a cube root of abc. Okay, and then last but not least, part F, we have a negative 2xy to the 3rd over a 4th root of 32 x to the 3rd y to the 5th. Okay, now let's be careful in the bottom. Let's simplify the bottom as much as we can before we do anything as far as rationalizing goes. So we get a negative 2xy to the 3rd. Now, if I separate everything out in the bottom, I get a 4th root of 32, 4th root of x to the 3rd, and a 4th root of y to the 5th. Now for square root of 32, I could write that as 4th root of 16 times 4th root of 2, right? So that's going to give me a 2, and then I'm going to get a 4th root of 2. Okay, for the 4th root of x to the 3rd, that's x to the 3 over 4. And we can't really do much with that, so we're just going to put that back underneath this 4th root. Now y, 4th root of y to the 5th, I'm going to get a y to the 5 over 4, which is y to the 1 plus 1/4. So I'm going to get a y outside and just one y on the inside, right? And then my top is still negative 2x y to the 3rd. So now what do I need to multiply by? Well, in order to make the 2 a perfect 4th power, I need to multiply by 8. So then I get 16. To make x to the 3rd a perfect 4th power, I need one more x. And to make y a perfect 4th power, I need y to the 3rd. So I need to multiply the top and the bottom by 4th root of 8x y to the 3rd. So now if I do that, in the top, I just get negative 2x y to the 3rd, 4th root of 8x y to the 3rd. And then in the bottom, I'm going to get a 2y. And then this is going to become 4th root of 16, which is 2. And then I'm going to get a 4th root of x to the 4th, which is x. And a 4th root of y to the 4th, which is just y. So I get all the stuff in the top didn't change yet. And in the bottom, I'm going to get a 4xy squared. So I'm going to get a negative 1 over 2 from the 2 over 4. My x's are going to cancel. 2 of these y's will cancel with 2 of these y's, and I'll just be left with the y up top. And then, of course, finally, we're just left with the 4th root of 8xy to the 3rd. So there's our final answer. Okay, so that concludes this video on simplifying rational expressions, or radical expressions, I should say. So I hope you enjoyed, and I will see you next time.